The curve y is x to the power 4 minus 3x cubed plus 3x, has points of inflection at B and C. The line passing through B and C intersects the curve again at points A and D. This is shown on the following diagram. A. Find the second derivative of y. It's quite easy. So dy over dx, it's what? It's 4x cubed minus 9x squared plus 3, and hence the second derivative becomes 12x squared minus 18x and plus 0 because 3 is a constant. And B. Find the coordinates of B and C. B and C are points of inflection, so we know that necessary condition is that the second derivative should be 0. So equating the second derivative to 0, we get that 12x squared minus 18x should be equal to 0, and we can see that we can factor out 6x, so it becomes what? 2x minus 3 is equal to 0. So x is 0, or x is 1.5, and it's clear from the diagram that x is 0, it's for B, and 1.5, it's x coordinate of C, and we need what? Points, coordinates of points, so we should find y, corresponding y values, and when x is 0, y is 0, so y of 0 is 0, and y of 1.5, just using a calculator, it's negative 0.5625, and hence it becomes coordinates of B 0, 0, and coordinates of C, it's 1.5, negative 0.5625. The next shows that the equation of the line through B and C is negative 0.375x. So we need just what? The equation of a line through 2 points. How to find the equation of a line? Using a formula for gradient, it's rise over run, and it becomes, or we can write that it's gradient is what? Negative 0.5625 minus 0 over 1.5 minus 0, and you may use a calculator, and it becomes negative 0.375. And notice that we should emphasize that y-intercept is 0, hence equation of a line becomes negative 0.375x. Or if you don't write this, you should write plus 0 to emphasize that y-intercept is 0, because if you write directly like this, you will lose a mark. Notice that, be aware if question is to show that, and notice that you cannot write directly the answer. It may be clear, but you should show it in detail. So you may write y-intercept is 0, and you write this, or without this, but write like this, and hence it's negative 0.375x as required. And D. Find to 3 decimal places the x coordinate of D. What is x coordinate of D? It's a point of intersection of the line with the curve, and you can see that in general there are for roots for points of intersection. And how to find a point of intersection? We should consider simultaneous equations. One, it's equation of the curve y is this, x to the power 4 minus 3x cubed plus 3x, and together with y is. Since y is, we can what? Just equate expressions. So we can consider x to the power of 4 minus 3x cubed plus 3x should be equal to negative 0.375x, and you can see that there will be 4 roots, and you may and actually you should use a calculator, and you may consider what 2 graphs and consider point of intersection or points of intersection. But I want move it to the left to get and to consider plus 0.375x to be equal to 0, and I will consider only one graph, and I will consider point of intersection between this curve and y is 0, but y is 0 is x-intercept, and I need zeros or roots of this function, zeros. So it looks like this. X to the power of 4 minus 3x cubed, and you can see that we can add these two terms up, and it becomes 3.375x window, and I need x-axis, so I may write absolutely any y value, so that y to be equal to 0 must be included. And for example, let's consider x to be 5, and let's see what we get. And we need what? These points, x-intercepts 1, 2, 3, and notice that we consider x to be positive, and it's point B where x is 0. The second root, you can see that it's approximately 1.5, and you can guess that it's 1.5, it's point C, and the next point, this point, it's a required point D, and if we extend it to negative values of x, we can find coordinates of y as required, but we don't need x coordinate away, so we choose calc and 0. If you use 2 graphs, you need intersect, you need to find point of intersection, but I need zeros, and left bound this, right bound this, guess this, and you can see that it's 2.427 to 3 decimal places. So x coordinate of D is 2.427. It's required to 3 decimal places. The next, now consider the general curve y is x to the power 4 minus mx cubed plus nx, where m and n are real and m is positive. Find the x coordinates of the 2 points of inflection in terms of m. So we should do actually the same, the second derivative e. So the first derivative is what? 4x cubed minus 3mx squared plus n, and the second derivative, it's what? 12x squared minus 6mx plus 0, and equating it to 0, we can factor out what? 6x, and it becomes what? 2x minus m, and it should be equal to 0. X is 0, or x is m over 2. M is positive, so this point will be to the right. And what do we need again? 2 points x coordinates only of 2 points of inflection. So it's one point, it's another point. The next, let these points of inflection be B and C. The line through B and C intersects the curve again at A and D, given XA is less than XB, less than XC, less than XD, so that it's absolutely similarly to this graph. Write down the coordinates of B, 1 mark, and definitely its point to the left is 0, so y of 0 is 0, hence coordinates of B becomes 0 and 0. Find in terms of M and N the coordinates of C. C is the second point of inflection, so x coordinate of C, it's what, m over 2, and we need y coordinate, and y of m over 2 becomes what, x to the power of 4 minus mx cubed plus nx, and substituting m over 2 for x, we get the next m over 2 to the power of 4 minus m over 2 cubed plus n m over 2, and it becomes m to the power 4 over 16 minus m to the power 4 over 8 plus n m over 2, and it's 2 over 16, and you can see that it becomes negative m to the power of 4 over 16 plus n m over 2. So coordinates of C become m over 2 and minus or negative m to the power 4 over 16 plus n m over 2. Find in terms of n coordinates of C. Found. The next, shows that the equation of the line through B and C is, and absolutely similarly, we have 2 points. Let's rewrite B 0 0 and C with coordinates m over 2 negative m to the power 4 over 16 plus n m over 2, and we write gradient is what, rise over run, or minus m over 4 over, or negative m over 4 over 16, negative m to the power 4 over 16 plus n m over 2 minus 0 and m over 2 minus 0, and you can see that we can multiply each term in the numerator and denominator by 2 and divide by m to get finally that it's minus negative m cubed over 8 plus n, and we should emphasize that y-intercept is 0, or similarly to the previous question, if you write y is what, minus a negative m cubed over 8 plus n x, without this you should emphasize that y-intercept is 0, so you write plus 0 here because answer is given and your question is to show that. So we get as required. Next, so it's G, shows that XA is, and you can see there are 7 marks, and definitely since there are unknown parameters we cannot use a calculator. We should find it without a calculator. But what is XA? XA, it's a point of intersection it's one of 4 points of intersection between line and curve. And we know that what point or points of intersection is what simultaneous equations, and one equation is this and another equation is our curve. Where is it? It's x to the power of 4 minus mx cubed plus nx. X to the power of 4 minus mx cubed plus nx, and it becomes simultaneous equations. And again, y is we can equate these expressions, so it becomes x to the power 4 minus mx cubed plus nx is negative m cubed over 8 plus nx, and you can see nx cancels, and you can see it's a polynomial degree of 4, and in general there are 4 roots, and there will be 1, 2, 3, 4 roots, because the graph is absolutely similarly to this. And how to solve this? Sorry, I lost x here, and you can see that we can factor out or just divide each term by x, but x is 0 is a root, and it's actually point B. We can just divide by x because we have written that x is 0 is a root, so it becomes x cubed minus mx squared, let's move it to the left, plus m cubed over 8 is equal to 0, and there are 3 remaining roots, point A, point C, and point D. And it's in general it's it's a polynomial or equation of degree of 3. And how to solve the equation of degree of 3? We need a root, and in general you should guess a root, or it should be given a root, so that we divide, or we can factorize by dividing or something like that, so that we get linear factor and quadratic, and equating into 0 we solve just quadratic equation using discriminant or something like that. Do we know a root? Yes. Why? Because we know point C. The second point of inflection. It's also the second point of it's another point of intersection, and with respect to this polynomial, it's also a root. So we know that x is m over 2 is a root, and now we can factorize it. What does it mean? So this polynomial can be rewritten as x minus m over 2 and multiplied by polynomial of degree of 2, ax squared plus bx plus c, and it's equal to 0. I will use synthetic division, but you may do the next. You may just expand it and equate it to this, and equate coefficients in front of same powers of x, and you can see that for example a is 1. We can deduce it now. Why? Because x cubed can be obtained only when x is multiplied by this, and to be 1, a is 1, and you may continue to find this. But I want to use synthetic division. How to do that? We write this value here. Notice that it becomes x minus some value as a factor, but here we write this value without minus. And coefficients of what? This polynomial degree of 4. If it's polynomial degree of 4, there must be 4 coefficients, and coefficients are what? 1, negative m, 0 because it's coefficient in front of x, it is absent, so it's 0, and just a number m cubed over 8. Then this value again, and this multiplied by this, and right here, so it's m over 2, and we add this up, and right here, so negative m plus m over 2, it's negative m over 2. Then this multiplied by this, and right here, so it's what, negative m squared over 4, and again add this up, and right here, so it's negative m squared over 4, and again this multiplied by this, and it becomes what, negative m cubed over 8 and 0. Notice that this value is remainder, and since m over 2 is a root, there must be 0. If you get this value which is not 0, it indicates that there is a mistake, because it's a remainder, and if it's a root and it's a factor, it must be 0, and it gives us what, this. So this polynomial becomes, or this factorization becomes what, 1x squared minus m over 2x and minus m squared over 4, and it must be 0. It's actually this factorized. And to find the remaining two roots, point A and point D, we should solve this. You may use discriminant, but I want to complete the square. How to complete the square? Since A is 1, we just divide this coefficient by 2 to get x minus m over 4 squared, and minus, always minus this value squared, so minus m squared over 16, and continue minus m squared over 4 is equal to 0. So x minus m over 4 squared is what? It's 4 over 16, so together it's what, 5m squared over 16. Hence x minus m over 4 is plus minus root 5m over 4, and since x a is the least value, or it's negative because it's to the left from 0, point B, and you can see that x may be what, m over 4 and plus or minus, and you may guess that for if we use plus, we get what, this point, it's positive, but if you use minus, you get negative value, and it's x coordinate over the point A, root 5m over 4, and actually it's given, yes, so that xa is m over 4 minus m over 4 over root 5. And also it is given that m is positive. And the last question, hence find the exact value of xb minus xa over xc minus xb. 2 marks, absolutely easy. So xb minus xa over xc minus xb, and xb it's 0, xa is this, the obtained value, but minus and this, so it becomes negative m over 4 plus root 5 m over 4, and xc it's our this m over 2 minus 0, and you can see that multiplying each term in the numerator and denominator by 2 and divided by m, we get that it becomes minus a half plus root 5 over 2. We need the exact value, and it's the required exact value. And that's all for this question.